Hello, welcome to Tech Transform. From this session, I'm going to start one of the new technology called Spark. So this is the Apache Spark, and we are going to understand what is a Spark and why we are going to use this. So first, understand the concept of big data. So nowadays, we are creating millions and petabytes or zettabytes of data in a single in a single day. Let's say in Facebook, we are generating continuous data. Twitter, we are generating continuous data. So this massive environment and data sets are going like exponentially. We can't rely on the single machine for the processing and all those computation. So Spark provides you the distributed processing. So it's a lightning fast computation engine. Basically, it's an open source distributed general purpose cluster computing framework. So you have massive amount of data and you want to do data analysis, and you have to do a lot of data analysis. Then in that case, Spark is very useful because it's going to distribute all over your data using the cluster computing framework, and it can divide your chunks of data into the smaller bit of portions to the clusters. It's a very fast and general purpose processing language. It's very fast because its main methodology is Spark used to work in memory. Every write or read operation it is going to do in memory rather than disk. So it's very fast. Run programs up to Spark's. It's the latest, and there is a competitor is also called Hadoop, and that becomes old. So Spark is the latest thing, and we can say that Spark programs runs 100 times faster than the Hadoop MapReduce because it's in memory. And if you want to run Spark in disk, let's say, then it will be 10 times faster than the running Hadoop on disk. Why it is following a DAG engine that is called direct acyclic graph. Direct acyclic graph is like, let's say you want to perform n number of operations on a particular n number of operations on a particular data set. Then even unless and until you are not finally collecting the whole computation you want to do. Let's say you did n number of pre-processing of data, and then finally you want to collect the data. So Spark, what it does behind the scene, the Spark runs direct acyclic graph. So it will create a linear graph, and it will follow a path, and it will give you optimized path. At finally, let's say I want to find the word count, and before that word count I am doing a lot of steps. So finally, what Spark will do at the last time, it will give you optimized solutions. What is the best suited solution for running that particular task? So that's the direct acyclic graph is the latest concept, and it's embedded in Spark framework. And it's also built around one main concept that is called resilient distributed dataset, that is RDD. It's you can treat it as it is going to hold your data, and this data is not going to reside only on a normal single machine. This is going to distribute it across clusters of computers. uh, it's highly scalable, so we can understand how this is scalable. So we used to write whatever you're going to perform your task, you are going to write a driver program. You can, using Spark context class provided by Spark framework, you can write a driver program in any of the APIs provided by Spark. Either you can write in Java, Python, or Scala, but we are going to use Scala in our upcoming sessions because Spark itself is written in Scala, and a lot of features you're going to get if you're going to use Scala as API for Spark. And the next come thing is cluster manager. Cluster managers is in Spark. What it takes the user input as a driver program or code from the Spark context, and there are a lot of nodes attached to this cluster manager. So this cluster manager is going to decide it needs to call which node for particular task, and how it's going to divide the data, and finally how these nodes are going to report back with the final result, and how this cluster manager is going to accumulate all the data and uh, combine all the results and give back to the driver program to the user as what user is going to perform. So it's highly scalable. So you can treat it this we can you can do in your in your setup you can do horizontal scaling. Means you can, as much as processing you need, you can add as much as node in a horizontal way. And one also main important concept is it's all Spark is only a computational engine. It is not a processing engine. A data it's not a uh, data save engine where you're not going to save your data. It's just only you can process your data. So for saving the data in a distributed manner, it can run on top of Hadoop. It can access HDFS files. It can access file setting on Amazon S3, file setting on Google Cloud Platform, also Azure, Microsoft Azure. So it's only a computational engine rather than a storage engine. The main component of Spark is Spark Core. Spark Core is mainly your RDD, what I told previously. All the normal data pre-processing and all those writing data, perform some operations, and all those comes under Spark Core. Then Spark Core is the backbone of all the components associated with the Spark. Let's say Spark streaming. Spark streaming is like you are getting massive amount of data on, let's say, online transaction you are doing, and you want your data processing also online on a real time basis. So what you have to do, Spark streaming will give you data in a real time basis, and also you can process your data on a real time basis and show the result to the user. Spark SQL is like, basically RDD is unstructured. Spark SQL is like it's giving you an interface like you can interact your whole data sets distributed across clusters using Spark SQL like syntax. And MLlib is also, it's very growing. MLlib is actually machine learning library provided by Spark itself. So what it is going to you, it is going to provide you a lot of machine learning algorithm written in Spark, and you can run those algorithms across multiple clusters of data sets. GraphX is also, you can say, it's a combination of, let's say in a Facebook you have a group of social friends, and how these all the friends are related to each friends. So it will give you a GraphX visibility of the whole data if you want to populate a graph. So this is GraphX is very useful. So also we can say we already have a Hadoop, then why Spark? So because Hadoop is mainly used for batch processing, but using a Spark you can do a real time data processing and also batch processing. That is not possible for using Hadoop. And also in Hadoop, processing is very slow because the Hadoop MapReduce works on disk. It is going to read and write to the disk, so there is a lot of time is going to elapse in those read and write operation disk. As you know that RAM or in memory is very fast, so Spark utilizes in memory or RAM to do all its operations, so that's why it's very fast. And also this uh, it's going to perform give you all the unified, it's a called, it's, you can say it's a unified engine also, because in Hadoop you have a separate of ecosystems, like for data getting data stream of data, you have to set up Spark Storm. Then other there is a yarn manager for cluster manager of work. Then you have a separate if you want to write some query on, if you want to write some execute some query on data, you have to use Pig or Hive. You have to do separate configuration. Here you can see all those come in a single bundle: Spark Streaming, Spark SQL, machine learning, libgraphics, and Spark Cores. So these are the basic main features of Spark, and this is going to be work in coming decade also, because Spark is a very fast for in a did in it's a very fast lightning fast computation engine in the field of big data. So that's all for the introduction point of for the Spark. We are going to cover a lot of different features, components, all the components, and do the hands-on with all those programming using in coming in the upcoming session. So thanks for watching. Have a good day. Bye.